Hello, let's start with the first lecture of this course in GIS and remote sensing that is dedicated to the analysis of physical basics of data acquisition, and the main aim of this course is dedicated to give some basis of the analysis of multispectral image. So we will analyze optical image in this course. The lecture is divided in 3 topics: light and radiation, spectral signature, and time series. As you know, light is all the object emits and reflects light, and there is a particular interest to analyze which kind of radiation can be observed with our eyes, that is the image that you see on the left, while on the right you see an image acquired from a sensor. And in this image you see that the vegetation is in red. This is a false color composition, and this kind of radiation is a radiation that is reflected from vegetation, and this kind of radiation we don't see this kind of radiation with our eyes. So it's very important to analyze the electromagnetic spectrum. The electromagnetic spectrum is one form of energy propagation, and with the sensor we analyze the data that arrive from a different wavelength, from ultraviolet to microwave. In the optical remote sensing we analyze data from visible, ultraviolet visible, to far infrared, that is the thermal infrared wavelength. As the source of this radiation is the sun, it's very important to analyze what is the energy that is absorbed by the atmosphere. And we see that starting from the radiation from the sun, 23% of the sun's energy is absorbed by the atmosphere, about 48% is absorbed by the Earth's surface, and about 29% is reflected back to the space. So it's only a small percent of the total radiation from the sun. And the atmospheric influences are very important in our work, because some of the radiation is scattered, and there is a different kind of scattering, atmospheric scattering and Rayleigh scattering, and so the atmospheric influences is dependent on the wavelength, as in the atmosphere there are some particles that can absorb and scatter the radiation. Here I put only 2 slides on the laws that are the basis of the radiation principles, that are the Kirchhoff's law, the Stefan Boltzmann law, the Planck radiation law, and finally the Wien displacement law. As you see, all the data that we collect from a sensor is high correlated with this law, and the emission, in particular the emission of radiation from an object, is a function of the wavelength. So the different object with the object with different temperature can emit radiation in different wavelength, and so it's very important for remote sensing. Why it's important? Because we have to analyze the interaction of this radiation with the Earth surface. So we see all the we see that the sun, the source energy for the radiation is the sun. During the first step, the sun arrives to the surface through the atmosphere. So, as I told you before, it's important to analyze this interaction with the atmosphere. When the radiation arrives to the surface, there is the interaction of the radiation with all the objects on the surface. So the radiation come to the sensor. Then the sensor can record this energy, and the sensor can transmit this information to a processing station, to an acquisition station, a processing station. Then the data are ready to be used from the users for different applications. Only one step on the interaction of radiation with the Earth surface, because the surface is not flat, but there is some roughness. The surface is very it has a topographic plane that is different from one point, one side to other, and if the surface is flat, the radiation is completely reflected. But in our case, the radiation is diffuse as or has a reflection, a Lambertian reflection. And we see that only a part of this reflected energy can be collected by a sensor. And this part is related, so this part is related to the roughness. And the roughness is one of the information that we can collect in the field to analyze this reflected radiation. And here you see some different plot of crops that have a different roughness. When the radiation arrives on a leaves on a tree, we can analyze the different kind of radiation. We have the radiation arrive from the source. Some lights are reflected from the tree and from the leaves. Infrared and green light are reflected. Red and blue light are absorbed. And this is very important because with our eyes we see the leaves green as the green light is reflected, while we don't see the infrared with our eyes. But infrared, it's very, very important to analyze the state of the vegetation, the health of the vegetation. And to analyze this radiation, we can introduce the concept of spectral signature.